Good day to you. So I'm going to try and do a very quick introduction to R as a lesson. I've been struggling to teach this to myself, mostly because I don't really love R. I mean, I can see the appeal, but I find myself slinking back to using Python at the first chance. And I have to teach myself this and at least make myself aware of its uses. So I decided to make a video uh, taking the opposite view that I loved R, and I'm going to try and sell you on it. I'm going to try and teach you it, and hopefully you might find some value in it in that. Um, so R, I believe, developed from S. It's one of the older statistician languages. It's quite heavily used in marketing. It is actually quite useful because it is, when you get used to it, it is just typing in new commands, and a lot of these commands can be stored up in a notepad, like I did here. It does have big data connection, so if you were wanting to connect it to Hadoop, you can do that. Not at that level to tell you how to do that. It does come with some very handy R demos to learn it. I haven't chosen to do that. I went and got some data from Kaggle, which is data from Netflix, Hulu, Prime, and Disney Plus, to indulge in the concept of, if I was to get a new entertainment package at this time, which one might I enjoy most? And I'm not going to really answer that properly, but I'm going to try and show off a few ideas that you get out of this. So the location of that data is in the CSV, as you can see. If you want to go to Kaggle, set up an account. You can get R for free, which is actually really useful. I do actually feel, if you're a big Excel user, maybe this is worth a go as a sort of a different way of dealing with your graphs and your plots. As you can see, I've loaded the data up here. You can scan through it like this. You can see if there is a space in the title of anything, it adds in a dot, a full stop, might I say. It currently has the original data I got. It wasn't very data clean. I had to write some Python script to do the cleaning, and as you can sort of see, remove things like the percentiles and turn them from string into ints. But so trying to sell it to you as how you would use it if you're an Excel user, you might type in head and your, what we call the data frame, and that would list roughly what you've got up here. But if you're working on a console, that's how you'd show yourself the data. You can type in help on anything that you're not sure of, which is really fantastic for learning stuff. As you can see, I've looked up LM, which is the way we sort of do linear regressions, fitting linear models in the data. You've got a bunch of help there if you wanted to take a weave and didn't know where to go. As in anything else, you can go to Stack Exchange and get the same data from there. You type to to go over how you sort of get this data into these systems, if you type in the name of the variable you want to call the data, a left arrow with a straight line, the function that you're looking to use, and if you fill out that function, that's how you pass data between variables in R. I prefer equals personally, but this is their way of doing it. You do have that squiggly line that sometimes appears in these functions. In this case, I'm taking data dollar runtime, which goes and gets from this file data and goes and looks up runtime within it, and squiggly line to have the second value, and data dollar IMDb to go and get the IMDb value. Linear regressions are, if you don't know, I'm not expecting you to have detailed knowledge on data analysts and that sort of thing, but the idea being is if you've got a plot of data, this M as the X and Y, and you'd see this at school, is probably an idea of how steep the value is. If it's really steep, it's a good chance that any increase in X by 1 is going to be a big increase in Y. And to put you in a mindset why this might make you be interested and might be something that tells you how numbers relate to each other, is because if M is a very big number and X was amount of workers and M was a huge number that of cost, it might change your value of how many workers you have on or something else. It could be that M being very tiny could mean that you want lots of workers. I don't know why I've chosen workers, but you get the point that 1x resulting in big increase as an average over over your data set can have some big meanings if you're trying to go and analyze it. R is quite useful because you've got things like this. You can go and build a summary, very single word, brackets, what you're trying to put in. It'll go and get you the min, first quartile, median, third quartile, max. Give you all the standard deviations, the error, t-values, all that sort of thing if you're interested in a very quick box and whisker plot type way of looking at the data. Lets you know how split up the data is. You can do it with any data frame. So you can sort of see set of summaries here. So if I was to go, I want to know as a very quick idea of who is the company that's got the most videos on. I've got it here. I've got an idea of max, min, well, not that the max matters, for it's all one per row, but you kind of get an idea of being able to look at the data and get an idea of what's going on. You can have a look at counts. You could imagine that if you've ever sat there with Excel and played around with it and tried to do all these summaries and stuff with formulas, being able to do it at single type is valuable. You've got the ability to do a histogram. This one is histogram of the results. Let's change it to data. And let's change it to IMDb. And there you go. You've got your breakdown to sort of be able to have a look at the standard deviation and the split across the data. You can clearly see that IMDb ratings average around 6. They start to peter down very quickly after 8. Lower than 4 is relatively rare. Lower than 2 is almost unheard of. So if we were to start following a ChrisDM methodology, what you'd like to use R4 is looking for hypotheses. Sorry. The idea being is you've been asked to look at a bunch of data and you've been asked to look at and investigate something. A really good starting point is just to throw everything at the wall. And one way of doing that, and where R really excels in this, is your ability just to jump around and look at silly graphs and just produce one in one line. So this is a graph of why long movies are better. That's a crazy hypothesis, which in this case doesn't seem to be true. You do have to ask yourself, there is one movie that's somehow over 1,200 minutes long. Which movie that is, I have no idea. I'm tempted to go and look at what platform it is on and try and find out what it is, but that's something I can do in my own free time. I could do a proper heat map and show you this heating up in the middle, but it's not that interesting, and it's what you expect. Basically, you could look at this graph and you've got a hypothesis of long movies are better. They're more likely to get high IMDb rating, and therefore we want to watch a long movie. This contradicts that. You'd probably go, I'm not going to investigate that further, and it's a good summary of the basic ChrisDM methodology. You know, like it's a really simple. There's pages and pages written about this stuff. But the idea being is moving on from this. What R lets you do is there is a library called the Grammar of Graphics, which I'm going to go into next. The Grammar of Graphics is really useful because it lets you stack graphs on top of each other and lets you be very exploratory in your data. And it came about around 2003, the idea being to basically build an ability to write a program to generate a full graph just from words. And when you really get your head around it, this can be an Excel killer, because when you know that in a sentence you can generate a graph, it can save you a lot of time. So that's it for me for my first video. I'm sorry that it's boring. I hope you'll join me in my second one, where I try and go through the grammar of graphics and go through ggplot2. I hope you find something to learn from this. Have a good day.